Morning Year 10, a little bit of a different starter today. Just a little bit of revision about some of the bits and pieces we've been looking at over the last couple of weeks, and something a little bit curveball for you, something that we haven't looked at all, just as a bit of a reminder of something else that you should have seen before. Okay, so you've got 4 questions here. Calculate the area of a circle. Take the value of pi of 3 if you like, that's not a problem. Take the value of pi of 3, just calculate the area of that circle. Should be easy. Find the surface area of that cuboid. Don't forget you've got 6 faces to a cuboid, but you can make life easy for yourself. Calculate the volume of this prism. Should be fairly straightforward. I'll just make clear that the height that they give there is the vertical height. The vertical height there is 5 centimetres. And then find the missing side x of that triangle. That's something that's a little bit different. It's not something that we've covered in the last few weeks, but it's something that you should have covered at some time in your time at the school. Don't worry if you haven't or if you can't remember. If you'd like to copy down those examples quickly, just sketch out the examples, have a go at them, see how you get on, and then turn the video back on and I'll go through the solutions for you. Okay, I said take a value of pi of 3. Just to make life easy for yourself, what's the formula for the area of a circle? It is pi r squared. So if we take a value of pi of 3, so we've got 3 times, the radius is 4, what's 4 squared? It's 16, 3 times 16 equals 48 centimetres squared. I think if you took a more accurate value of pi, you're going to get sort of 50.6, something like that, centimetres squared. Don't worry, if you've just taken the value of pi of being equal to 3, that's fine, it comes out as 48 centimetres squared. The important thing is you being able to remember that formula. Find the surface area of this cuboid. So this end and the opposite end are going to have the same area. This side here and the side at the back are going to have the same surface area. The roof and the floor are going to have the same surface area. So that can make life simple for us. So taking each end, 3 centimetres by 4 centimetres, 3 centimetres by 4 centimetres, surface area of that end is 12 centimetres squared. 2 lots of that gives me 24 centimetres squared. Front and the back is 3 centimetres by 6 centimetres. 3 centimetres by 6 centimetres is 18 centimetres squared. 2 lots of that, 2 lots of 18 gives me 36 centimetres squared. And then finally, the roof and the floor, 4 times 6 is 24, 2 lots of 24 gives me 48 centimetres squared. How much does that come to altogether? 24, add 36, add 48 gives me 108 centimetres squared for the surface area of that cuboid. What would the volume of that cuboid be? Just as an additional, 3 times 4 times 6, 3 times 4 is 12, 12 times 6, 72 centimetres cubed would be the volume. Just as an additional little question. Calculate the volume of the prism. Right, whoa. Volume of the prism. We know the height of this triangle is 5 centimetres, the base is 4 centimetres. Sorry if you didn't see that. That's my fault. So 5 centimetres times 4 centimetres to give me the area, but what have we got to do? We've got to halve that, haven't we? We've got to halve it. 5 times 4 is 20. Half of 20 is 10. So the surface area of that triangle is 10 centimetres squared multiplied by 6 gives us a volume of 60 centimetres cubed. Oh, nearly got that wrong. 60 centimetres cubed. Right, okay, find the missing side x. Right, this is something that I haven't covered with you since we've been out of school. It's actually Pythagoras' theorem, isn't it? Okay, yeah, it's Pythagoras' theorem here, which says that if you've got a right angled triangle, the sum of the squares of the two short sides is equal to the square of the long side. So you've got to rearrange that. So that means that x squared equals 10 squared, take away 3 squared. So x squared equals 91. Yeah? 10 squared is 100, 3 squared is 9, 100 take away 9 gives me 91. So x squared equals 91. It's going to be roughly 9.5. And I think it accurately comes out, yeah, I think it comes out as about 9.5 centimetres to 1 decimal place. 1 decimal place, 1 dp. Okay? So that's a quick starter. Right, the main topic we're going to be dealing with today is spheres. Balls, spheres, spherical objects. So let's flick through the pages there so we can get onto that. A lot of this stuff that I'm flicking through here, you will recognise it is things that we've been dealing with over the last week or two. Right, volume and the surface area of the sphere. These formulae you will be given in an exam. So don't worry too much about trying to remember them. They may change that, because they tend to like changing the rules, but at the moment they tend to give you these formulae in an exam situation. And all I'm asking you for you to do today, volume and surface area of the sphere. The surface area of a sphere is given by this formula, 4 pi r squared. 4 pi r squared, where r is the distance from any point on the outside of the sphere to the centre point of the ball. So any point on the outside of the ball, the sphere, to the centre point of that sphere is that distance r, the radius. So that is a formula you need to take notice of. The surface area of a sphere is 4 pi r squared. So write that down. The volume of the sphere we've had a look at briefly before. The volume is 4 pi r cubed, 4 pi r cubed divided by 3. That's a formula. It does say there, you will usually be given this formula in an exam. Okay? So you need to write down those two formulae. And all I'm asking you to do for today's exercises is just simply take those formulae, think about the fact that you're dealing with a ball, a sphere, in each of the examples, and have a go at some simple problems with them. Here, they're asking you to find volume of a sphere with a radius of 3.2 metres. Just plug that 3.2 metres into the formulae that you've written down and see what you get as a result. Surface area of a sphere. Plug the distance that you've got, and remember they've given you the diameter here, they've not given you the radius, so you've got to do what with it? You've got to halve it, haven't you, to get the radius. Think about the fact that they'll quite often do that. They'll give you a diameter when you've actually got to be considering the radius. So don't get caught out on examples by not realising that. And this one, the volume and surface area of this hemisphere, well, just be careful. The volume is going to be half what the whole ball, the whole sphere would be, the volume of the whole ball, so it's going to be half of it. But for surface area, be a little bit careful. Yeah, the surface area of the dome part is going to be half of your formula. But don't forget that if it's asking for surface area, you've still got to consider you've got the base, which is a circle, pi r squared. Now, I'm not going to go through those examples. I think they're fairly self-explanatory. But I'll just go back to the two formulae that you do need to know, the volume and surface area of the sphere, to be able to have a go at some of the questions that are set for you on the attached worksheets. So make sure that you've got those written down. The surface area is 4 pi r squared, the volume is 4 pi r cubed divided by 3, and make sure that you understand that it is r that you're considering the radius. Be careful if they give you diameters. That's the end of the presentation for today. Thank you very much for your attention. Good luck.